What's up, guys? In this video, we're going to be trying something different than my normal content. We're going to be trying out the 2026 MIT Integration Bee problems in the Qualifier. And I've never seen these problems before, so I'm looking at them fresh. And I have the timer right here in the corner, and I'm going to time myself. Alright, so I'm going to open the test and then start the timer. Okay, 3, 2, 1. Okay. Okay, so this one, wait, it's just signed as just an odd function, so that's just 0. Okay, for this one, you just have that you can just use sub u equals e to the x, then you get e to the 2026 u, and that's just 1 over 2026 e to the 2026 u. So that's just 1 over 2026 e to the 2026 e to the x. Sorry if my writing's a bit bad because I'm literally using my mouse here. Anyway, so now we have this problem here, and it seems like we're just going up in increments. So just repeat every single 3. So whenever you go from 0 to 3, that's just equal to 0 plus 1/3 plus 2/3. Because you have 0 to 1 is 0, 1 to 2 is 1/3, and 2 to 3 is 2/3. So all the way until 2025, I think, it just becomes 2025 over 3, which is 635. And then you go from 2025 to 2026, and that's just 0. So therefore, this is just 675. All right, so problem number 4. Wait, how did you do this one? This is super interesting. Okay, wait, so when x is positive, it just becomes 2026 x dx. So that just becomes 1013. But when x is negative, that's the bigger issue. Oh wait, you have a 0 there whenever x is negative. So this term here is 0. And then you have another absolute, then you have another x there. So that's, yeah. So, yeah, it seems to just be 0 for these guys. So you end up getting that it's 1013 plus 0, which is 1013. I'm very shaky on this one, though. Okay, so this one, I think you just rationalize the denominator. That's just x plus 1, square root x plus 1 plus square root x minus 1, all over 2, I think. Then this becomes 1/3 x plus 1 to the 3/2 minus 1/3 x minus 1 to the 3/2. Because it's normally 2/3, but then we divide by 2. So 1/3 x plus 1 to the 3/2 minus 1/3 x minus 1 to the 3/2. So that's the answer to that one. Okay, for this one, I think we just expand out the definition of cosine h. So that's 1 plus e to the x plus e to the negative x over 2. Then that becomes square root of over 2 e to the x, e to the 2x plus 1. And then we can just get rid of the e to the x from the denominator, because then that becomes e to the x times e to the 2x plus 1 over 2e to the 3x. And then we can just use sub. So that becomes t squared plus 1 over 2t cubed. And do we like substitute tangent? So that becomes secant over 2 tangent square root tangent times secant squared. Wait, that doesn't work. You know what, I'll come back to this one. Okay, so number 7 is 2 to the log x is just e to the ln 2 times log x. And yeah, and this is just equal to x to the ln 2 over x squared. So x to the ln 2 minus 2, and that's just 1 over ln 2 minus 1, x to the ln 2 minus 1. Yeah, what? This was so much easier than number 6. I don't know why. All right, number 8, we have 0 to 1/2 of, then that's just a geometric series. So that's x squared over 1 minus x dx. Then we can just use polynomial division. That becomes, so 0 to 1/2, negative 1 minus x, because then that gives x squared minus 1. Then we have to add a 1, 1 over 1 minus x dx. Then we get negative 1/2. Then this should be minus 1/4, I think. Wait, no, it's minus 1/8. What am I doing? And then you have plus 0 to 1/2, 1 over 1 minus x dx, which is also like 1/2 to 1 of 1 over x dx, which is just ln 2. So that's just ln 2 minus 5/8. This is also proof that ln 2 is greater than 0.63 or 0.625. So that's pretty interesting. Okay, so problem number 9. We have x squared sine x dx. I think we just integrate by parts here. Yeah, it's just repeated integration by parts. So we let u equals x squared, b equals negative cosine x, and because negative x squared cosine x plus 2 times integral of x cosine x dx. Then we just do it again. U equals x, b equals sine x, negative x squared cosine x plus 2x sine x minus then 2 integral of sine x, which is just plus 2 cosine x. So the final one is negative x squared cosine x plus 2x sine x plus 2 cosine x. All right, problem number 10. Wait, I need another sheet of paper. Okay. And this is just a random sheet of paper I'm using, by the way. Okay, so how would he do this one? What is this? I'm not sure how one would do this and incorporate 2e to the x in the denominator. Okay, so let's move on. So number 11, this one is just a circle. Because when you graph it, you have that as a circle, but then you have to subtract 1/2 from the circle. So suppose that's that, then you have something like that. So you're just trying to find the area of this region here. I don't know if you can see it. But then just 1, 1, the angle is 2 pi over 3. So that's 2 pi over 3 minus the angle is 120 degrees. So that's just square root 3 over 4. So that's 2 pi over 3 minus square root 3 over 4. Okay. Oh, this one is just a standard nested radical. So you let t equals square root x squared plus x plus square root t, yeah, wait, t equals square root x squared plus x plus t. Yeah, I think that's right. So you get t squared minus t equals x squared plus x. So that means that t equals x plus 1. And then it's just integral from 0 to 1 of x plus 1, which is just 1 plus 1/2, which is 3/2. Pretty standard problem. Wait, let me get more paper real quick. There we go. Okay, this one just is straight up binomial theorem. So, but wait, isn't it just cosine x plus I sine x to the power of 5? And it's just the real part of that. Pretty cool. So that's e to the 5ix plus e to the negative 5ix. Oh wait, this is just 2 cosine 5x. And then that's just 2/5 sine 5x. Alright, now we have this one here. This should be pretty standard. You just let x equals t squared, then it becomes arctan 2t arctan t. Now it's just an integration by parts. U equals arctan t, v equals t squared. Then it becomes t squared arctan t minus integral of t squared over t squared plus 1. Yeah. And then this becomes, which is just minus t plus arc tan t. And then when we plug in x equals t squared, we get x arc tan squared x minus squared x plus arc tan squared x. So we can just express it more compactly as x plus 1 arc tan squared x minus square root x. Alright, hopefully this is somewhat legible. Alright, moving on. Problem number 15. Ooh, what is this? Oh wait, these guys are just redundant. These guys just disappear. So this guy just becomes 0. That becomes 1. Yeah, this guy also is redundant. This guy becomes 1. This guy disappears. So all we're left with is 0 to 1000 of 1 plus ceiling x plus floor x dx. And the integral from n to n plus 1 is equal to 1 plus, then that's n plus 1, so that's n plus 1, so, and then there's an n. So 1 plus n plus 1 plus n, which is 2n plus 2. And we're going from 0 to 999. So therefore it becomes 2 plus 4 plus all the way to plus 2000, which is 1000 times 1001, which is equal to 1001000. Okay, we have just under 7 minutes left, so let's see what we can do now. Alright, so problem number 16. So we can just straight up simplify everything by using the definition of the inverses. So we get square root of cosine squared, then over tangent squared, sine squared, which is equal to square root of cosine squared times cosine squared, because that's tan squared is sine squared over cosine squared, so that's sine squared sine squared. So that's equal to cosine squared over sine squared is equal to cotangent squared x, and the integral of that should just be, so this is 1 over sine squared x, which is equal to, it's 1 minus this is cos squared. So that's equal to 1 minus cosecant squared x. And cosecant squared x, I think, has derivative cotangent x or minus cotangent x. It's, I think it's, yeah, it's cosine x over sine x. So yeah, it's negative cotangent. So it becomes x plus cotangent x. Okay, this one, how do you deal with this? Oh wait, you just use King's rule, you just use x equals negative x. Then it becomes 0 to infinity of e to the negative x squared, and that's just square root pi over 2. Ooh, what is this? Is this just like you use product rule on sine squared x over x? What does that give? That becomes negative sine squared over x squared. Then you have plus 2, yeah, this is just negative sine squared x over x. Yeah. Ooh, what is this, dude? So obviously first substitute log x, because then that gets rid of the x in the denominator. That becomes log u log u over u, and then du. Then we get rid of that, so u equals log x, v equals log u, and that becomes v log v dv. And from what I understand, this is just, wait, how do you do this one? I think you just integrate by parts now, because you let w equals log v and y equals 1/2 v squared. So it becomes v squared log v over 2 minus integral of v over 2, which is v squared over 4. So therefore it's like log x squared and then log, and then I'm not going to write it out, so it's log squared over 4. I'm just doing LL for log, so pretend that just works out. For this one, how would you do this? So what happens when you plug in x equals pi over 2 minus t? And that becomes sine squared, which is 1 minus cosine squared. So that becomes sine squared. And that becomes sine squared, yeah. And then it just reflects, and then you just get pi over 4. Okay, now we should probably check our work, because there are a bunch of ones I haven't answered. I've answered 18 of them so far, and I still need to check my work. Okay, so this one I already know is an odd function, so it's 0. So for this one, you just, yeah, you use sub. And then this one is just 0 plus 1/3 plus 2/3, which is 675. And then, yeah, it's actually 1, but then you multiply it by 2025 over 3, because there are 675 intervals. And then 2025 to 2026 gets nothing. And then you have this one here. When x is negative, I'm pretty sure that this just vanishes completely. And I can probably prove that by something like induction. Yeah, you can just prove that this vanishes by induction or something. Because basically this vanishes when you're done. Okay, then this one is good. This one is good, I think. Yeah. Okay, so hopefully this is good. Alright, I'll just pause it here and let's check our answers. Let me go ahead and go to the page. Let's see our answers. Alright, so I'm gonna go ahead and mark them in a different color. So I'll do it something like that. So we have this one's right. This one is right, I think. This one's right. Right. I'm surprised I got that one right. Oh, it's not minus. Ah, dang it. I should have been more careful there, honestly. It's that? Wait. Wait, that's actually so simple. What? Huh. I'm surprised. So anyway, that one's wrong. This one's right. Right. X squared. Yeah, that's a minus sign. So 2x. Yeah, this is right. Wait, what happened? Okay, so this one I didn't answer. Oh wait, maybe. Oh, you just split it up and subtract it from 1. Oh, that's so smart. How did I not see that? Oh wait, this is just pi over 3, not 2 pi over 3. What am I doing? That's 3 halves. This one is not. Wait. Oh, yeah, I messed up. I actually don't know how I messed that up. That. Oh, just the negative of that. So there. Yeah, and I meant to say this is over 2, because that's what I put down on my paper, as you can see here. It's just really hard to put things down here because I'm writing things with my mouse. So that and that. I'm just marking this right because I wrote it down correctly on my paper. All right, anyway, so we got 1, 2, 3, 4, 5, 6 wrong. So that gives us a score of 14. And the ones we got wrong are this one because of this 2 factor here. Then this one because it should be a 1. Then this should be minus. And then this should be plus. Yeah. So in general, I should be more careful about the signs of these integrals when I consider them. But otherwise, I think I did pretty good. So let me know if you enjoyed this type of reaction content or live solving content, and I'll try to do more of them in the future. So thank you so much for watching this video. Please subscribe if you'd like to